Predictive analytics is used to determine customer responses or purchases as well as promote cross-sell opportunities. Predictive models also help businesses attract, retain, and grow their most profitable customers. Understanding this, we have come up with this predictive analytics tutorial. Now, before we go ahead with the session, I'd like to inform you that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. You can check out the details in the description below. We will also be coming up with a lot of high quality videos on computer vision, cybersecurity, and cloud computing. So please do subscribe to our channel and click on the bell icon so that you can get a notification of our upcoming videos. Now let's have a quick glance at the agenda. We will start off by understanding about linear regression, then we'll have a demo on linear regression. After that, we will learn about logistic regression, and finally there'll be a demo on logistic regression.
Learning objective of this module, the total module, this predictive analytics, right? The linear regression, the logistic regression, linear discriminant analysis. All right. Learning objective of this session is going to be what is a simple linear regression and what is a multiple linear regression. These are the two main objectives for this session. And we'll have a pop quiz as usual. So what is the equation for a simple linear regression?
Y equal to mx plus c.
Y is equal to mx plus c. Now I have a different question. Okay, let me first write it down. Y is equal to mx plus c. Here, you mean to say the y is the c is the, what is c here? Sorry?
Intercept on y-axis.
Is the intercept, right? This m is the, what is m here?
Slope.
The slope. Slope, or you can call the coefficient of x, right? Now what is y here? What is the y here? Dependent variable, or what you could call it as, it is a predicted value of y for observation I. You have to put always yi and the y cap. Therefore, whenever you have to tell a simple linear regression equation, it is always starts with yi, y cap is equal to mx plus c. Or you can put mi xi. Since it is a simple linear regression, okay, you can mention it as y is equal to, y cap is equal to mx plus c. So now someone asks you, what is a simple linear regression model? Now I'm going to ask you, what is a simple linear regression model? How does it vary? So the simple linear regression model is given by capital Yi is equal to B0 plus B1 xi plus E, the error term. This is very, very important to note, guys. So whenever we mention about the prediction, we give it as y cap and there is no error term here. When you are going to tell for the population, you must always present it in the Greek letters, that beta, E, and instead of E we can put it as epsilon I. So what am I trying to tell here is, if I have an x and y axis, right, and this is a linear line, let me change the color. For B0, for a unit change in x, what is the unit change in y? This is x-axis, this is y-axis. For one unit change in x, delta x. What is a unit change in y? Delta y. Right? So when we are asked for a simple linear equation, y cap is equal to mx plus c. I think it was also mentioned in your video. We should always mention it as y cap. Why? Because predicted value of y for an observation I. For I observation, what is your prediction? What are you going to predict? That is why you are always going to mention it as y cap. Right? So here you are not predicting anything. Y intercept. So this is what you call it as dependent variable. Here we call it as a dependent variable. This is also a dependent variable, but this is a prediction value of y. You do not have the actual y. So whenever we want to write a linear regression, you mention it as y cap is equal to mx plus a. Vijay, is it all right?
Yes, sir.
So for one unit change in x, what is the unit change in y? That is the prime concept of this simple linear regression. For that matter, regression itself. Even logistic regression will be solving the same thing for a unit change in x. What is the unit change in y? That is what we are going to find it as part of your regression model. Right? Our second question comes: can we have more than two independent variables in simple linear regression? Can we have more than two independent variables in simple linear regression? That becomes a multiple linear regression. Right? Now, the second question: what is the equation for a multiple linear regression?
Y cap is equal to m1 x1 plus m2 x2 plus m3.
Perfect. Y cap is equal to m1 is also good. B naught plus b1 x1 plus b2 x2. All right. You mention that Greek letters beta, epsilon, odd for population. This is what we are going to predict. So we always use B, the alphabets. So in our beginning of the statistics class, I always used to mention. So beta, the Greek letters always used to mention for the population and the alphabets for the sample. All right. This multiple regression is just an extension of this OLS, ordinary least square regression. What is that ordinary least square? That involves more than one explanatory variable. More than one explanatory variable we have, then we call it as a multiple linear regression. Right? Now, name few techniques to deal with multicollinearity in the data. How to deal in multicollinearity in the data?
Principal component analysis.
Okay, how do you identify whether there is multiple collinearity in the data? Whether there is multicollinearity in the data?
There is a correlation between big correlation between two independent variables. So
correlation between two independent variables. All right. So, so any other option? In regression, what happens is when we try to run a regression, none of the coefficients become significant. Is significant. It leads to a question whether there is multicollinearity in the data. When I'm trying to run a linear regression, if none of the coefficients are significant, I hope you know what is significant, right? Based on the p-value in the overall table, based on the coefficients value, you arrive at the p-value, right? So none of the coefficients become significant, then there is a presence of multicollinearity in the data. You have to recheck that. Next, one more important concept is VIF, variance inflation factor. Variance inflation factor. There's not part of this scope of this session. Probably next session or the other session we'll be discussing what is VIF. But roughly I'll tell you what is VIF. VIF is given by the formula 1 divided by 1 minus R squared. What is R squared?
Correlation coefficient, covariance coefficient.
Coefficient of determination. We call it as a coefficient of determination. Right? What does R squared try to tell? It measures the proportion of the variation in Y that is explained by the independent variable X. Some variance present in Y. Some variation is present. how much is my predictor X variables, the independent variables, is able to explain it. That is called as an R squared. We are going to predict Y, right? End of the day. So how much Y, prediction of Y, is able to do by my X variables. That is what we call it as an R squared, right? So if it is by default thumb rule, we'll have it as 5. It is nothing but if you have 80% R squared, right, you'll get an VAF value of 5. If a value more than 5, we call it as a highly correlated, the presence of multicollinearity in the data. We'll see that in detail in the next session, right? And one more thing which I wanted to tell here was, so here I mentioned the explanation by the regression, right? How much variation in Y is able to explain by the variable X. Let us check it out, how it is. So in the X and Y axis, I draw a linear line. So there I'm going to predict a value, or 1 second, let me make the axis bigger. This I call it as X axis. This I call it as Y axis. All right. So in the total sum of squares, this is called as total sum of squares. In the total sum of squares, how much is my regression able to explain? Sorry, up to this it comes. Regression. We call it as regression sum of squares. And how much is my unexplained variance? What do you call it as unexplained as? What do you call the unexplained variance in the total regression, the total sum of squares?
Sum of squared error.
We call it as error. Sum of squared error. Sum of squared error. Perfect. The error is nothing but sum of squared error. Sum of square. Yeah, sum of squared error is correct. So in the total sum of squared error, how much is my regression able to explain? How much is my regression not able to explain? So I'll show you visually in Excel also how is this regression, how much regression is explaining, how much regression is not explaining it. Right? The regression is nothing but the independent variables, whatever I have taken, how much is it able to predict the variation in the variable Y. I'll show you very clearly in Excel, and by the end of this session, you'll have very clear understanding about the regression concept, right? So in the simple linear regression, so here y is equal to b0 plus b1 x1 they have mentioned, but you can put it as y cap is equal to b0 plus b1 x1. In the simple linear regression, it is when if it is more than one variable, right, we cannot explain it in the 2x's. All right. So we have an industry application. We have two industry application. One we'll see it, and after that we'll go to one case study, and then we'll have look on the one more industry application, and then we'll solve the second case study. So I'll make sure one is explained. We have 30 variables. At least I'll take 10 variables and I'll able to try to solve it in Excel and I'll show you. All right. Can somebody take a lead and read this question, the case study? Someone please, Vijay, if you could.
Industry application, linear regression in sports analytics. Sports analytics is a booming field. Owners, coaches, and fans are using statistical measures and models of all kinds to study the performance of players and the teams. Billy Bean, the manager of Oakland, has met Peter Brand, a young Yale economics graduate with radical ideas about how to assess players' values. Rather than relying on selectors' experience and intuition, Brand uses linear regression, selecting players based on their on base percentage, OBP, while ignoring their perceived weaknesses. Brand and Bean use this methodology to hire undervalued players. With 1/3 the budget, Billy Bean's team performed at par with the highest paid teams. This led to evolution of a new stream of analytics known as cybernetics.
Cybernetics. So I hope if someone has watched the film Moneyball, has anyone watched the film Moneyball?
Yes.
So it was just taken from that. So if you had known, right? So the cybernetics, the term was formed only after this way of picking the players, right? On base percentage, OBP, right? So if you had watched the movie, they had very little budget to hire the number of players, right? So after big depression of the Oakland, the team, right? So he wanted to win the matches. So he used a different technique. So even certain players were hurt, and the base players were very less for them. So using his techniques and ideas, he has picked the players of very less price, and then still they were able to compete the overall the match. Right? So you could read this. What is cybernetics? I have given the reference. So if you have not watched the film, watch the film Moneyball. So it is very good. So how they have hired the players. So they've used the basis of this OBP was based on the linear regression. That's what they have used to pick the number of players. Let me go to the case study which I wanted to discuss now. The salary prediction. In an organization, salary of an employee depends upon various different factors. Right? Based on the given data, build a model using simple linear regression to predict the salary of an employee based upon the experience of the employee. Now, I'll go to this I have solved it. Anyway, we'll solve it new. So we have years of experience and salary. I'll put it in the new Excel sheet. So years of experience and salary. So as the years of experience increases, the salary will also increase. Is that true or not? So this is a linear variable. As the salary increases, the years of experience, as the years of experience increases, the salary of the person also increases. Now I want to predict a person, a new person, or say an HR in the company. A person comes with 5 years of experience and is asking a salary of 1 lakh, something abnormal, right? So you have to predict the right value. What is the apt salary to give to the person? It is based on the years of experience and the salary. So if you could plot, let me just try to plot here. So as experience increases, the salary increases. Yeah, salary, and the salary increases. So if a person comes with 5 years of experience, so you could plot for 5 years what is the right value. He could ask something around 55,000 or 60,000. He's asking abnormal 1 lakh or 1.2 lakh, right? So in that way, we could predict. We want to predict apt way, right? We want to predict the right salary. How are we going to predict? We are going to use a simple linear regression to predict the years based on the years of experience. What is the right salary? Now I want to introduce a new term. I will not tell it as a new term. Now, what is the scope of this of the regression that we are going to build? We have an years of experience of the employees between 1.1 years and 10.5 years. So if any employee who comes to the company between this experience, only between this experience, I'll be able to predict the right salary, a predicted salary. If a person comes with 20 years of experience, my model fails. We have a point of diminishing returns. So if someone is from the MBA background, there is a point of diminishing returns. So in marketing, if I spend 1,000 rupees, I'm able to get a 2% increase in sales. Again, if I'm spending 2,000 rupees, my sales increases by 4%. Again, if I keep on increasing the 1,000 and 1,000 values for the marketing, my sales does not get increased. right? There is a point of diminishing return. Beyond a point, if I'm spending 5,000 rupees, there is not going to be 10% increase in the sales. We call it as a point of diminishing returns. Similar, applying the same concept to our regression, my model will be able to predict a new person who comes only within experience of 1.1 to 10.5 years of experience. If someone comes between, if I do not have 8.5 here, if a person comes with an experience 8.5, I'll be able to predict what is the right salary for him. I'll be able to predict. If a person comes with 20 years of experience, my model fails. With 25, 15 years of experience, my model fails. Beyond a point, beyond a confidence interval of my regression, if a new data point comes, I will not be able to predict the right salary for the person. Is that clear, guys? Is that clear? Any
Yes.
doubt here?
Yes.
So we have a confidence interval. Only between the range that I have taken, I'll be able to do the prediction perfectly. Right? So it's very simple to do it in Excel. I select these two variables, go to data, data analysis, the regression. V1. So for representation purpose, let me delete all these things, because if I start writing the formulas, so it will be very difficult. So data analysis. So I have taken only the, I'll delete it. This one I tried it. The Y variable is the salary, and the X is the years of experience. And I'm going to pick the labels here, right? And I want to show the value. So in very simple way, I'm able to use option regression in Excel, and I'm able to come up with the R squared values, the adjusted R squared values. So standard error, right? So the total adjusted R squared was something around 90%. Right here, just for representation, since I taken it, showing 69%. Now we'll see each and every variable how to solve it using the formula. Right? It's very simple, but you should know how an R squared is derived, how an adjusted R squared is derived, and how an standard error is derived, right? How an B0 B1 is derived, right? So you have given me an value y cap y bar is equal to B0, that is B0 plus B1 x1. This is the formula you have given me. Now my prediction comes between like a person with 2.5 years of experience. What is the salary? This is my objective. Let me place the objective at the beginning of the session, beginning of solving this question. For the 2.5 years of experience, what is the apt salary? Even though the data points are very less, this model is not a perfect model, but still, just for explaining purpose, I have taken. Right? In the real data, I have around 30 data points, which will be sufficient to explain. Right? I have solved it for all the 30 points. Now, so what happens is, like, I have to go down, I have to show you what is it and how to do it. So I'm taking only the 10 points. Is that okay, guys?
Yes, sir.
All right.
Yes,
So,
sir.
and one more objective here is to learn what is MSE, RMSE, MAPE, like our sensitivity value, the specificity value, and the precision, recall, the accuracy in classification problems. Now we start solving a regression problem, a continuous value. So for continuous value, you cannot put the values in the confusion matrix. So you have to use a matrix such as MSE, RMSE, MAPE. Right? I told you last time, before time, we'll be solving, when we come to the predictive analytics, I'll explain you what is MSE, RMSE, and MAPE. So only if I solve it using the formula, you'll have a better understanding what is MSE, mean squared error. So let me just add a couple of cells here. I'm taking an average value of my X variable and an average of Y variable. Okay? Average of Y variable. Now I want to predict yi minus y bar right? Yi is nothing but this variable minus y bar is nothing but the average. Give f4. F4 is like locking the variable. So I'm just copy pasting the formula to all the cells. So what happens? The negative signs are present here. To overcome the negative signs, I'm just taking the square value of this yi minus y bar. Similar to another problem that we had solved. Similar to how to find an variance and standard deviation. It's all again the same formula. Right? I'm just taking the square value of all the variables that I have found here. yi minus y bar. Right? Let me just put in box over here. Now next is xi minus x bar. Xi minus x bar and xi minus x bar the whole square to overcome the negative sign. Right? Again xi minus x bar. I'm just fixing it. And I'm taking the square of all these values. Alright, so I'll use the same box over here. Now I want to find xi minus x bar into yi minus y bar. Right? So xi minus x bar, we have solved it into yi minus y bar. So I have a value, right? So I'm taking the average of all these values and average of all these values. So it may confuse you. I'll just explain you in detail how to solve this again. And now our objective is to solve what is B1, what is B0. Right? If I know what is B0 and B1, I have y value here. Sorry, I have to find the y value here. Here, if I know the B0 and B1, I could put the values over here and I could find my y bar. What is the y value? For the years of experience, 2.5. Is that right, guys? Is there any confusion here so far? So my objective is to find B1 and B0, right? If I could find B1 and B0, I could impute in this formula and I could come up what is the predicted value. Now I have a value B1. How to find B1? B1 is given by this divided by the total x1 minus x bar the whole square. So I have found a value B1. Right, and B0 is given by, so I have this y formula here, then B0 is given by y bar minus B1 x1. Alright, so I want to find the B0 here is equal to, what is the y bar here? I'm taking the overall average minus, what is B1 here? B1 into x1. So I found two important variable, what is B1 and B0. So if I had found what is B1 and B0, I could impute for the new variable. For the variable 2.5, B0 plus B1 into x1. What is the value? His predicted salary is around 51,590. Guys, I am seeing a lot of silence here. So do you have any doubt here or shall I keep going? Or do you want to be precise only in Python?
Sir, can you explain it once more?
Yeah, all right. So how did I find B0, B1 or what do you want me to explain?
No, just like for some just to summarize.
All right. I'll summarize.
Yeah.
So I'm taking yi minus y bar the whole square. The y bar
Okay,
is
sir.
given by the average value. To overcome the negative values, I've taken the square of the yi minus y bar. So
Yes,
I will
sir.
get an values. Again, xi minus x bar. This is also to overcome the negative values. I use the formula xi minus x bar. Here I will put it as x bar. Alright, so xi minus x bar into yi minus y bar. This is used to find a variable b1. So to find b1, the coefficient of x1, you have to divide this value by this value. Alright, so don't get too much complicated. We are not going to use this in the real time. So I wanted to show you what is MSE, RMSE and MAP. On the way, I myself created an objective. What could be an predicted value for the years of experience 2.5? What could be the salary for the same? Now my objective, one more objective, this objective I have solved. What for the years of experience 2.5, what is the salary? Now I want to find how good is my model. How good is my model? How good is my model is explained by MSE, RMSE, MAPE. Now, how good is my model is explained by Y predict value. Y predict.
Sir, sorry to interrupt, just 1 second. The initial equation y bar is equal to b naught plus b1 into x bar. It should be x bar, right?
This one here? Here I have, okay. This we can put it as
b1 star x bar, right?
b1.
Because
no. I'll tell you.
No.
This is going to be x1 only. Why? See, for r, no, it is not one. I'll put it as I, bi and xi. Because I'll tell you why. In the y predict, I want to predict the value of y. This is the actual, right? This salary is nothing but y actual.
Okay.
Now I'm going to predict y here. How am I going to predict y? Using this formula b naught plus b1 into x1. So this is the actual, this is the predicted. So this applies for all the records here. So how will I put it as x bar?
So you imputed this while calculating b0.
Okay.
You used y bar and x bar.
So you want no. See, to find the coefficient, I do not have any other metrics other than taking the average. So this b0 and b1 is taken by the overall average.
Yeah, got it, sir. So the second equation b0 is equal to y bar minus b1 into x bar.
Okay, this one you want me to. So the terms, okay, x bar.
Now I got it.
Even your question is even more precise. Wait. What you're trying to ask is if you are going to put x bar here, why not x bar here?
So instead of y bar, we should write y cap or something.
Yeah, this is actually y cap. That's what I wanted to
y cap. Yeah.
Sir, I have a question.
Yes.
So
yes.
BI, in our case, BI is constant, right? We have just calculated B1 and we are using it everywhere. So it will not be BI, correct?
It should be B1, yes.
This is B1, sorry. This is B1. Oh, the big problem, what I tried. Okay. See, here, what did I put? Here, the formula, what I have written is, it is Y cap. So, since I was not able to mention it as Y cap, I put it as Y bar. This is actually Y cap.
Yes.
So, what? 1 second. If I go back here, it is Y cap. So I wanted to represent it as Y cap. Instead of that, by mistake, I put it as Y bar. So still, I think Y cap is equal to B naught plus B1 into this x1. I'll put it as x1, right? Here, why it is x bar? I do not have any other metric to find the overall coefficient. This applies for all the records. So I cannot take it only xi here, x1 here. So I'm taking the average of all the values to find the value, the coefficient b0 and b1. Here I should always take only the average. I should not take any one record. Sagar, am I confusing you, or Monica? Sagar and Monica, are you clear? Am I able to convince you, or is it still?
So we almost got it, but here, yeah, in this formula, so x1 will not be a constant, right? It will be xi because we are predicting a y cap, correct?
Yes, yes.
But b1 and b0 we are using as constant.
B1, B0 and B1 is always constant. Okay, I'll put it as.
Yeah.
So actually, when we write in linear regression formula, we'll write it as BA into XI.
Okay.
So
but there we have that assumption that the slope is not changing. So we use a constant.
It does not change. It does not change.
Okay, got it.
Okay. So here again, if you want to predict y, the prediction of y, it is given by B0 plus the B1. The slope is always same into the xi. So this is the actual. The actual it is predicting as 46,205, but my prediction is giving me only 39,351. My model is poor model here, like I said before, because the records are very less. But still, just for representation and understanding the formula how to solve the y-pred, I have taken it again. I'll just fix these values. B0 and B1 I am not changing. So the values, the overall values, using the formula, using this B0 and B1, I'm able to give the value y-pred. Now I have to find what is the error. The error is given by y minus y-pred, y actual. So to be more precise, y actual minus y predict. I think I'll be able to answer you this both question at last, or while summarizing, I'll be able to tell you. Right now, you just concentrate. How am I calculating this error? Error is given by the actual minus the predicted. So wherever you go, actual minus predicted, I'm calculating the error. To overcome this negative value, again, error whole squared, error whole squared, I am able to find it. The average of all these errors, I call it as mean, MSE, mean squared SQ squared error, mean square error, right? So this is of a different scale. I have to make it an RMSE. If I take RMSE, it is a root mean squared error. Since I have squared it over here, I want to bring it in the same units of this y variable. I want to bring it in the same units. That's the reason I'm taking it as square root of MSE. I get the value RMSE. So these both metrics are very important. And one more important metric which I wanted to tell you, this is not the part of the scope of this session, but still, since I have covered this MSE and RMSE, I wanted to cover this MAPE also, mean absolute percentage error. How do I calculate the mean absolute percentage error? Error percentage absolute mean, always remember it in the reverse way. We'll be solving it many times throughout the session, but still, first, the error is given by the error divided by, I'm sorry. So absolute, first of all, absolute error divided by the actual. All right. So I'm taking the values for all. Now I'm taking the average of all this values and I convert this to a percentage scale. So then I call this value as a mean absolute percentage error. So this is a different metric in time series. Throughout time series session we'll be solving this MAP. This is a different metric altogether. MAP, MAE again, mean absolute error. I have taken the percentage, mean absolute percentage error. So important thing to note here is I have taken the error y actual minus y predict and I have solved the mean squared error. Right? If I take the square root of it, I get the root mean squared error. For a new value which comes between the range of 1.1 to 3.2, what is the predicted salary? With the values of B1 and B0, I'm able to predict what is the salary for it. Now, how did I solve this B1? B1, I have found it by xi minus x bar into yi minus y bar. I have found divided by xi minus x bar the whole square. Right? So, to give, again, I made a mistake by y bar, mentioning it as y bar. Here it is y cap. Or just for simplicity, you mention it as y also. Y is equal to B0 plus B1 into x1. Now, to predict this B0, I have to take this B1 minus of B, what is the, I'm sorry, what did it, okay, the average of all the y value minus this B1 into the average of all the x, I'm sorry guys, average of all the x values. Are you able to understand this two part? If I'm not confusing you, do you want once more? Monica, Sagar, is it clear this part?
Yeah, somewhat, sir.
Somewhat. Okay. So in this formula, I do not know what is B0 value. So I'm just keeping this B0 here and I'm taking this B1 x1 value to the other side. Right. So whenever I want to find this B0, it is a comprehensive measure for all the records. So since I am taking all the records, this y value is taken as an average of all the x values minus of B1 I know and average of all the y records. So it is always given by average of all the x values and average of all the y values. Don't confuse this with this.
There was one sentence which was told in the video that best fit line will always go through x bar comma y bar.
Okay.
So I think that is because you are calculating B1 and B0 using x bar and y bar.
X bar and y bar. Yes, yes.
Yeah. Okay. Yeah. Now I am clear.
Right. Maybe this formula is confusing you. If there is no formula, I think you will be more clear. So I just confused you with this formula. Y cap minus, I'm just taking this B1 and X1 to other side. What happens? B1 into X1. So do not confuse this X1 and Y cap. This Y value is summarizing all these values. So I'm taking only the average value. The X values, I'm taking the average of all the X values to find the B0. It is a best value of this B1 and X1 under without any other condition. I'm considering this is the best line. The average of Y values and average of X values is the best line. So I'm taking the average of the X and Y value to find the intercept B0. Right. So, and one more important thing what I have told you is the error, how to find the MSE and RMSE. All right. So going back here, so the multiple R squared, how am I going to find the multiple R squared? Multiple R squared is nothing but is given by the correlation between the X comma Y. Correlation between X comma Y is given by the multiple R squared. So what is R squared? How do I calculate the R squared? R squared is always given by how much did my regression explain of the total. So that's how I calculate the R squared. Right here, it is all solving. The Excel has an inbuilt function to solve it, right? But still, you should know what is an R squared. How is it solving? Of the total regression and residual, how much did my regression able to explain? What is the adjusted R squared? It is calculated based on the degrees of freedom. Degrees of freedom of regression. I want to find. So what is the difference between this adjusted R squared and R squared? So I think it was all explained in the video. What is the difference between this R squared and adjusted R squared?
It does not consider the non-significant independent variables. For example, there is a population data, and there is one variable which is not contributing for the dependent variable. But by drawing the samples, drawing the sample from that population, there is some contribution shown by that independent variable.
Based on the independent variable. So to put it in simple terms, R squared, I'm just calculating how much did my regression explain, like what you explained, right? The adjusted R squared based on the number of values, based on the number of records. Records should also be considered here. The degrees of freedom is also very important to be considered. Considering the degrees of freedom, the number of independent variables, what is the apt value? So when for a simple linear regression, you may consider R squared. When you consider multiple linear regression, multiple number of X, many X values, many independent values are there, it's always right. Adjusted R squared is an apt value to consider whether my model is a good model adjusted R squared is a good metric to identify whether is my model performing good. All right, how do I identify the adjusted R squared? Adjusted R squared is given by I'll put it over here. Is given by 1 minus of, I'll put it in the reverse way. So I'll take it the residual sum of squares divided by the degrees of freedom, and the total sum of squares divided by the degrees of freedom. Since I want to identify the regression, 1 minus residual divided by the total sum of squares. Right? That is how this adjusted R squared is calculated. What is the standard error? Standard error is nothing but the square root of this residual. Square root of the mean square of the residual. I do not want to go again and explain this ANOVA table. It is going to take a lot of time. So what I'm trying to tell, we were able to solve each and every steps in Excel using the formula. Right? We are able to cross compare and get the right values of the regression table in Excel. Right? And we have solved this ANOVA table. I think you guys know how to solve it. Right? This F significance F is nothing but the P value. So P is low, the null will go. So the regression model is worth executing, right? How? What does it signify? The salary is a good predictor to identify the years of. The years of experience is a good predictor to identify the salary. All right. So is this clear? I took an extra step to solve it in Excel. There are 2 case studies to be solved in Python. So that is the only objective of the session. So I wanted to show how an MSE and RMSE and how this B0 and B1 is calculated in Excel. So was it worth solving? How do you find? Is it confusing? Is it okay? Shall I go to Python?
Yes, sir, it was helpful.
All right. So okay. We'll see the same in Python. We have 2 case studies. One is Airbnb and all right. All right. This is the student solution. Now I am importing the libraries NumPy, Seaborn, Pandas, and linear model. All these variables. Just importing it here. Just give me a moment. And the salary data. I'm just importing it. Head command showing me. So these are all the preliminary cases that we used to do. Describe gives me the summary of the years of experience the total summary. So the mean value of the summary is 76,003. Why it is showing different? We have taken only 10 records in Excel to represent it, but here I have taken there are total of 30 records, right? So if I wanted to show the 30 records, it would be very much confusing. So I've taken only 10 records. So the standard deviation is 27,404 for the salary, right? The years of experience is the standard deviation is 2.8. To find the distribution, I use a command SNS pair plot to see the distribution. Here we could see that the data is linearly distributed, right? And the correlation plot, here there is only one variable, so it is highly correlated. So is this correlation good or bad? Is this correlation good or bad?
It will be good. No?
Bad.
It is good.
Why?
Close to
Okay.
1.
Close to 1. So is it in multicollinear data or?
This is simple linear regression, so this correlation is good.
This is good. Actually, we are finding the correlation between the independent variable and the dependent variable. So always the correlation between the independent and variable and the dependent variable must be very high. Only then that it shows that it is a very good predictor to find the y variable. Here it is a very good predictor, right? So so any doubt here, guys? Any doubt? So why it is high correlation, why problem? Monica, Sagar, any doubt?
No doubt, sir. I'm good.
Okay. So the train test split. So we have seen it number of times. We use sklearn model selection. From the model selection, train test split. Right. Now there are two options to find the linear model, right? One from the stats library and one from the scikit-learn. Right. Let's first start how to do it in the scikit-learn library. Always in this sklearn, we must identify what is the we must give an object name for the function linear regression. Linear regression. I'm just referring it as regression model. Regression model. So in the regression model, regression model, what am I trying to do? I am trying to fit the values between what? NP. I'm converting this as an array because that was not in an array. X train, and this all is given because from the data frame we have extracted only this X train, right? So what happens is like it converts from a vector to the data frame to a vector. So I'm just converting back to an array. Reshape 20,1. How many? 30% is like 21 will be. And Y train. So we have fit the model, regression model for the X value, the train and the Y train. You forget this reshape and the NP array. I'm just converting it to array because what happens is when I was splitting this X and Y. So when I was trying to fit this X and Y from the data frame, since it had only 2 columns, it is just converting it as a vector. So some error was coming. So I'm converting it as an array and I'm reshaping it as 20,21.
So sir, this step will be required only when we are doing simple linear regression, because we will have only one.
So that that may be required. Yes.
Okay.
I'll show you why did I use it. So okay.
Yeah, I got the same error, so I had that question today.
Okay. So if you could see why test, right? It was not in an array. So if you could from the NumPy, you use an array. So this was the workaround. I'm converting it as an array and I'm converting it as reshape to how much is 1, 2, 3, 10, 1. So I'm just converting it to an array. So that's how the input is taken for this linear model. That was the reason I've used this NP array. Okay, that is nothing to confuse. So now what is the coefficient of the model that I have built? Right, now in the regression model, I want to find what is the coefficient of 0. It gives me the coefficient, 1 second guys. Regression model dot coefficient is always given in the 0. Alright, 1 second. Alright, therefore the coefficient, that's correct only. So for the years of experience, so what is the coefficient for the years of experience? The coefficient for the years of experience is 9202. 1 unit increase in the year of experience, the salary increases by 9202. That is an important takeaway here. Straightforward in linear regression, you will be able to solve. 1 unit increase in the years of experience, how much the salary increases? It increases by 9202. Alright. So what does an intercept mean? What is an intercept from your understanding?
Where the slope cuts the y-axis, the line cuts the y-axis.
Okay, that's perfect. That's theoretically. What is philosophically? In generic terms, you tell me. Philosophically, what is that intercept trying to tell?
When all independent variables are 0, what is the output?
Perfect. What is the output? Intercept is containing the effect of all the omitted variables that we have not considered in the model. For example, if I have taken 3 or for example 10 independent variables, it's not everything. My y variable may be explained by the 11th variable. Why 11th independent variable? That is not considered in this model. My 10 independent variables together was able to explain only 80% of the variation. By addition of one more important variable, it could explain still 5 more percentage, 85% of the total variation in y can be explained by that 11th variable. So we could have missed out somewhere. So that missing effect will be taken in the intercept. Right? Intercept is containing the effect of all the omitted variables that we have not considered in the model. That is very important to tell. Right? Therefore, the intercept for this model, I have to find the intercept, right? Intercept is given by a regression model dot intercept. Yes. So the intercept is 26049. If my x is 0, what is the default salary? If my years of experience, a fresher comes, what could be the right salary? We could give 26,049 rupees, 49 units. I cannot tell it as rupees. So that's what the end takeaway from this regression. What is the R squared? How do you find the R squared? Again, to find the R squared, I use regression model dot score. Regression model score, again I'm using that NP array, all those things. NP array of x train, regression x train, and reshape to 21,1 and y train. So 96% of the variation in y is able to explain by this independent variable x, the years of experience. 96% it is able to explain to me. Right now in the test set, how much is it able to explain? The same x underscore test. Right. So here the length of x test, or you can put 9, the remaining variables, comma 1. So 92% it is able to explain to me. So if a new variable comes in, I could given confidence 96% and confidence with the area, with the years of experience, 5 years of experience, this could be his salary, provided he is within the same confidence interval that I have taken to train the model. Else it comes the diminishing effects of the model. If I take beyond the range of the x variable that I have trained. Right now, option 2, using the stats model. Using the stats model here, a few things I have typed. I think this was the file which was given to you guys. I think this is the file that was uploaded in the Olympus. Right now, data train is equal to, I'm concatenating this P train, X train, and Y train. I'm making it the same again, same data frame. Right, and fit the OLS model, ordinary least squared model. How to fit the ordinary least squared model here? We import from stats model formula API, suppose, okay, as SMF, some name, stats model formula API. We am just giving it as SMF. Does not matter, whatever you give, it's just an alias name. Now I'm building in model, linear model 1. I'm going to give it as SMF1, ordinary least square regression. What does it mean? Formula is equal to salary. Salary is a function of years. 1 second. Okay, I could see here years experience. What is the data? Data is equal to data train, and I'm going to fit the model. Right now my model is fit, and what is my lm1 dot params? If I'm going to give, what is the intercept value and what is the years of experience, the coefficient value. Intercept is 26,049 and the years of experience is 9202. If you have to use, if you, anybody have used the R, only this is the only way to solve the regression. We'll get even further more details in R, in the stats model. Even here, only in the stats model, you'll get so many details. The adjusted R squared, F statistic, probability. But in the sklearn, you will not get, because this was developed by a statistician, that was developed by a programmer. So there is a primary difference. That's the reason we get more statistical information when I'm going to build a model using the stats model. Right? So what does the end takeaway from here? If 1 unit increase in experience, the overall years of experience, the total salary will increase by 9,202. That is how my coefficient variable able to contribute. So the learning objective of this session. So what is a logistic regression? What is a sigmoid function? Odds and the log ratio. Odds ratio, and you can add also a probability. What's in probability and odds, how to decipher it. Assumption of logistic regression. In addition to the contents that is mentioned here, we'll also discuss a sample example of an AUC and an ROC. I feel that little concepts are missing in the video. We'll see, I'll give you a sample, just 5 points that we'll take. So it lets you understand what is an area under the receiver operator characteristic. And solve a very famous logistic regression example using an Excel. How to form B0, the coefficients of the independent variables. Alright, by the end of this session, you must have a good understanding how to solve a logistic regression either in Python or Excel, and understand the concepts, the inline concepts. Whenever you go for interview, the first question they're going to ask us, they're going to shoot the questions only from the logistic regression, mostly from the regression. Either it can be logistic regression or the linear regression. Alright, so once you prepare this, once you complete this course and you put it in the resume, I know logistic regression, R, Python, SAS, put everything, there is a job guarantee. Because there is so much of demand for this particular, this model, this logistic regression model. This is an age-old tradition, but still, right now there is more demand in doing this logistic regression model. Alright, so just to break the ice, I have a small pop quiz. So is logistic regression a technique of an unsupervised learning or unsupervised learning?
The supervised learning.
Why is it unsupervised learning?
Because we are having target variable.
Yes, we do have a target variable. Right. Now, what is the shape of a sigmoid function?
So S shape.
S.
S-shaped. So because it is S-shaped, they have named it as sigmoid. Okay, it is actually a sigmoid function is an S-shaped curve. Right? Should we have a categorical dependent variable to apply a logistic regression?
Yes.
So, yeah. So the dependent variable should be either an ordinal or a nominal variable. Alright. So this is the linear regression and this is the logistic regression. The curve. So what happens here is, so what happens in the linear regression? So we do have a linear line, something like this. Alright. So what happens in the logistic regression? So the logistic regression is predominantly a categorical variable. It can be either from 0 to 1, either a 0 or 1. So there is no, I'll change the color. There is no point in having a values something greater than 1, something less than 0. Am I right? So how do we convert this to a sigmoidal curve? How do you convert this to a sigmoidal curve?
By using the logit function logs.
By using a logit function, we forcefully make whatever is less than 0, make it 0. Whatever is greater than 1, we make it 1. There's no point. There's no point in extending this line at all. Right? Therefore, so what is the form of an what would I tell? Okay. What I wanted to ask is, what is the equation for a logistic regression? What is the formula that you could call?
Exponential equation, D.
The exponentially. What is the formula for a sigmoidal function?
1 upon 1 plus e raised to beta 1 x beta 2 x2, like this.
Okay.
Where x are variable and beta are coefficient.
So you mean to tell beta naught plus beta 1 x1 plus beta 2 x2 equals to beta n xn. Is that what you're going to tell?
It's for sigmoid function. And
okay. The sigmoid function goes something like this. Sigmoid function is given by e to the power beta x, I'll put it as cap, and divided by 1 plus e to the power beta x. Alright, I'll just derive in a while how this sigmoid function is. Okay, I'll just derive it right now. How the sigmoid function is coming. This last week's. Now, what is the odds ratio? What is the formula of odds in comparing to probability? I cannot derive everything. Possibly few. How is this sigmoid function is derived? What is odds formula?
P upon 1 minus P.
P upon 1 minus P. So that is what you call it as an odds. Now, what is the probability? What is probability? Just put it in this. Sorry?
Odds by 1 plus odd.
Yes, perfect.
Odds.
So odds divided by 1 plus odds. So wherever you go, whatever you do, don't forget this formula. This is very important. Forget all the complicated things. Just don't forget to remember this odds and probability. Right? Now, if I have to derive an sigmoidal function out of it, probability divided by 1 minus P is equal to what you call it as odds. Let me add log to it. Log of probability divided by 1 minus probability is equal to log odds. We always use log odds. Right? 1 minus P is equal to e to the power log of odds. So when I take e to the power of log, this e and log get cancelled out. Let us just have this log of odds here alone. Right? Because we are going to use that in the formula. Right? Therefore, probability is equal to 1 minus probability into E of log odds, which is nothing but E power log odds minus P into E power log odds. Right? So if I'm going to take that to the other side, P plus P E power log odds. So this derivation and all, I'm just trying to explain so that you may not forget in the later. 1 plus E power log odds is equal to E power log of odds. Therefore, what do we get here? Therefore, the probability value is nothing but E power log odds divided by 1 plus E power log of odds. That's so you are going to derive this P value. We call this again a term called as maximum likelihood. Have you heard of it?
No, sir.
Maximum likelihood estimate. Just do some research. What is maximum likelihood estimate? This likelihood estimate, I'll show it to you. Why am I explaining this maximum likelihood? Because while explaining in Excel, I want just maximize. I'm going to maximize the likelihood estimate. If I'm going to maximize the likelihood estimate, I'm going to minimize the loss. Minimize the losses. So my objective here is maximize the likelihood estimate so that my loss term is minimized. As simple as that. All right. So I've just taken this log odds, this formula odds, and I've added an exponential term to it, the log term and an exponential term. And based on that, I've derived an P value. We call this as an maximum likelihood estimate, or you would call it as a famous sigmoid function. All right. Therefore, before making you confused, we'll come back again when we are trying to revise here. So as of now, you know what is an odds formula, what is an probability formula, based on which we have derived an P value, and we call that as an based on that we will derive the maximum likelihood estimate from the sigmoidal function. Is there any confusion here, guys? Isma, Monica. Okay. All right. So we'll again come back and revise. So this is nothing. This is not rocket science. This is very simple derivation. So we have converted this linear regression by forcefully making whatever is greater than 1. Whatever is greater than 1, you make it as 1. Whatever is less than 0, you make it as 0 by using the logistic model. Right. So I have 2 industry application. We'll solve one industry application. Okay, this is nothing. This is very simple. And then we'll go to Excel. We'll solve that using our traditional formula. And then I'll explain you what is an AUC, ROC, and we'll go to Python. All right. Can someone take and lead and read an real-time application where they have used this logistic regression and where they have succeeded? Can someone? Jay, can you please? Jaydeep.
Industry application, logistic regression for finding the best match. eHarmony is a popular online dating website. Nearly 4% of US marriages in 2012 were a result of eHarmony. According to Dr. Neil Clark Warren, many marriages ended in divorce because couples were not initially compatible. In 1997, Warren began an extensive research project interviewing 5,000 plus couples across the US, which became the basis of eHarmony's compatibility profile. Therefore, unlike other online dating websites, eHarmony does not have user browse others' profile. Instead, based on 29 different dimensions of personality, including characters, emotions, values, traits, etc., assessed basis a detailed questionnaire, eHarmony computes a compatibility compatibility score between two people using logistic regression based predictive models and optimization techniques to determine their users' best matches.
Best matches. So this online, this dating website, the eHarmony, they have taken various parameters, the personality traits, character, emotions, values. They have taken so many variables, and they are trying to build a best match for each and every individual using the logistic regression. Now they have even more advanced. If you go to the reference link, they're using very far more advanced techniques. This was an initial thing they have used in logistic regression. They succeeded. Now they are using even the photos, using the photos they have taken, and what all photos, what all angles. So basically, when a photo is posted, they do not look for all the personality traits, all those things, whether the person looks good or not. That's how the person initially values their partner, right? That's how it's mentioned in the reference link. So these people, they started building a model based on the photos. They started liking it, so they build a deep learning model also, and separately they have run a model to to find the best matches using the variables such as this emotion, values, traits, right? So they were able to come up with a good model at the end of it. So this is one of the real-time application. So that was the reason that we have put it over here, right? And before going to one more, okay, let's finish that almost. So this one more industry application, the credit risk assessment using logistic regression. So whichever domain you go, I'm not worried about it. If you're into the banking domain, if you're going to enter into a banking domain, they're more interested into the visibility of the model. How visible is your model? This is more of a white box model. The neural network, what we have learned, the random forest, what we have learned, it all is a black box model. We do not have an equation for it. Which variable, if you're going to evaluate, if you are going to tweak a little bit of a particular variable, how much is your dependent variable is going to change. We cannot come up with that kind of an equation in a black box model. Whereas in a logistic regression, one unit, if you are going to increase an x and x1 variable, how much unit increase in your dependent variable or decrease in your dependent variable. That is the speciality of this logistic regression, and that is the reason why still and bankers are using this application. Because if you're going to if you're going to use that as a credit underwriting somewhere, right? Loan underwriting. So a person with in US, like he's in black, he wants to come for a loan, and your neural network model says like you're not given loan, because your neural network model tells that he'll default by 20% or 30. I mean, there's higher possibility to default. He'll default by 80% or 90%. The black guy goes to the court and he sues the bank that he is not giving me loan because I'm black, right? So the bank cannot fight back because they do not have an equation. They cannot point to this neural network model and they can tell, because this model told me I'm not giving the loan to him. Whereas if he had used a logistic regression model, he could come up because of this so and so variable, and you can give an equation and you can validate because of this particular variable, because he had defaulted 2-3 times. So there is a possibility to default by so and so percentage. So that is where the bankers are still predominantly using logistic regression. Now they are trying to move, but I'm working for a banking sector, but still they are focusing only on the logistic regression day in and day out. They are not interested to go into any deep learning models or the neural network models. Right? So can someone take a lead and read this industry application?
The Basel Committee is a representation of more than 60 central banks constituting more than 95% of world's GDP. In its pursuit of monetary and financial stability and to foster international cooperation, it has rolled out Basel Accords. These accords particularly address the areas of risk such as credit risk, operational risk, and market risk. Logistic regression is by far the most widely accepted modeling approach in the area of credit risk, both for retail, that is individual, and non-retail institutional exposures. While lending to an individual, we use variables like age, income, education, employment status, EMI to income ratio, and credit score, etc. For corporate lending decisions, the variables are mostly captured through the financial statements as they depict the true financial health of a company.
But here again, for a retail individual, and what are the variables that we could take? The income, the age, the education, the demographics, and these we call that as in static data, and the dynamic data we call it as an the transaction data, which keep on changing, we'll call it as in dynamic data, and which are all same, we call that as in static data. Static as well as dynamic, they're going to take that. And why did I mention this example? Logistic regression is by far used widely accepted modeling approach in the area of credit risk. Not only in credit risk, in banking, whatever you are going to forecast. Forecast which is going to specific to user based, right? The customer base, they're still using in logistic regression. This is a case study which will solve it quite later. Before that, I want you to show one famous use case. This is taken from a very special book, right? So the loyalty of a customer is the dependent variable here. The loyalty, yes, dependent on what? The brand, product, and shopping. Out of these three variables, which is going to predict whether the customer is loyal or not loyal? For what can the company spend for marketing? Should the company spend on marketing for while allocating the budget? Should the company spend more on the branding, or should more on the product, or more on the shopping? How is the loyalty of a customer is validated? Right? The customer's loyalty is validated using the brand, product, and shopping. We'll come up with three coefficients: B1, B2, and B3, and B0 being the intercept. I'll just give the color. Now, so why did I take this simple use case before jumping to a very complicated? There's a specific reason. I do not want to write the formula again. What is the odds? What is the probability value? Now, what is the odds value? Let us cover all the things that they have covered in the video using the simple use case, simple case study, and we can go to the use case that they have given as part of our presentation. So, what is the formula for the odds? Forget the probability divided by the one. I do not want that. The complete e to the power z. What is the formula for an odds? Am I confusing you? What is the formula for an odds?
B1, sorry, B0 plus.
Okay.
Okay. Next one plus B2.
1 second. So B0 plus B1 x1 plus B2 x2 someone Bn xn. So to the
e to the power.
Sorry?
This whole thing is power of e.
Yes, that's what I wanted to mention. So this becomes a linear regression. So you have to mention this important term e. E to the power is very much important. E to the power beta naught plus beta 1 x1, whatever you're going to mention, it is called as an odds. That is odds, right? Going back. So now what is the formula for odds? It's nothing but exponential of, here let me give some default value. I will show you the power of Excel, how powerful is the Excel is. Complete, you can compute all this beta 1, beta 2, beta 3, everything over here, right? The odds is given by exponential of B1. Some product of B1, B2, B3, comma, this 3. What does it mean? What does it mean here, guys? What am I trying to do?
x1, b2, x2, b3, x3.
B3. So I'm just using a default functionality in Excel. Is everybody clear here?
Yes, sir.
Yes, sir.
So what does this dollar sign mean again?
Fixing the b.
I'm going to fix that value specific to that cell. All right. So I'm deriving an odds. So similarly, I'm going to derive odds to all the values, all the records. Now what comes the second one? The probability. What is the formula for the probability now?
Odds divided by 1 plus odds.
Perfect. Odds divided by 1 plus odds. That's how you're going to derive the probability. All these are going to change. These are all the 0.9999. All this will be changed. How will it be changed? By changing the coefficient value. How to find the best coefficient value? I'll just tell you in a while. What is 1 minus probability?
0.
1 minus of this.
Yes.
Right? Now, the next is y log p and 1 minus log p. 1 minus log, 1 minus p. This is very, this is the main reason why the power of logistic regression lies in this equation. Y log p plus 1 minus y log 1 minus p. Why am I telling it is very much powerful? What is the specific reason for it?
Our final formula.
If y becomes 0, this becomes 0, whereas this do not become 0. If y is 1, this becomes 0, whereas this does not become 0. Therefore, you will get an value. You will have a strong value at the end. Right? We'll see. Y into log probability. Similarly, 1 minus y into log 1 minus probability, or we have derived 1 minus probability. So you can see the beauty here. This, when the value is 1, so this becomes 0 and this is present. So your equation does not get void, right? Since it is in classification either 0 or 1, your equation does not get void. So that is the main reason we are using y log p and 1 minus y log 1 minus p. Now I'm going to sum up all the values of here. If you had seen the formula given by Mr. Mukesh, he would have done the same thing, but I'm just using an Excel to tell you. Right? Now we have summed up all the y minus log p and 1 minus y log 1 minus p. Now I'll show you. We'll go to data, solver. Right? You go to the solver and select objective. Objective is select the summation of y log p plus 1 minus y into 1 minus p. And type is maximize the log likelihood by changing the variables b0, b1, b2, b3. Make the on constraints. Okay, this shouldn't be negative. It can be negative. And give solve. It is taking a while, and it is giving you a right intercept and the coefficients of the independent variable. There is a problem with this one. Yeah. Okay. So now we got the perfect B0, B1, B2, B3 just by using the Excel itself. Right? So with this, I'm not telling you, I'm not promoting Excel. So I'm just trying to explain the formula for each and every variable and how using Excel we are able to do it. Right? Now here we could see the maximum by increasing log likelihood. What was our B0, B1, B2, and B3? If I just copy this and paste it over here, yes, and so how are you going to interpret the coefficients? So I think it was mentioned, right? The coefficients are interpreted by exponential term, right? So this is what you call as odds. This is what you call as an odds. Now, what is the probability value for the same?
Odds divided by
1 plus
Odds divided by 1 plus odds. I'll just explain it to you in a while. So this B1 is representing brand. This brand, this product, and this is shopping. Which customers are more loyal? Brand based customer, or the customers who are most product based, or the persons who are shopping? These are the three parameters that I have taken. Right? So brand based, how do you come with brand based?
The probability.
So how do you derive a wording for that?
Maximum likelihood.
No, forget maximum likelihood. Now come to linear regression, our normal regression. Just form a sentence for it. 1 unit increase in so and so. 1 unit increase in spending in brand, right? Your possibility of customer becoming more loyal increases by 78%. All right. If more the amount of spending, 1 unit increase in spend in product, your customers becoming more loyal is going to become 54.64%. Right? 1 unit spend in shopping, the loyalty of your customer is going to increase by 64.33%. Isn't it more similar to our linear regression?
Yes.
We have converted the non-linearity to the linearity by using the odds and probability. By rule of thumb, something greater than 1, if it is 1.0, guys, your probability is nothing going to be 1 divided by 1 plus 1 is nothing but 50%. 50%. So once you look at the odds value should be always something greater than 1. If it is greater than 1, then that variable is giving positive contribution to your dependent variable. I see silence here again. Do you want me to explain this again? Based on this, I can even derive a confusion matrix.
Just one question. If the probability is less than 30%, I mean, if the probability is 30%,
okay,
the sentence will be like this. If we spend 1 unit on brand, the probability of that customer becoming loyal will increase by 30%.
30%. Right. That's correct.
That sounds contradicting. 30% means it is close to 0. It is towards 0, right?
That's what. We'll have a cutoff value. It is going to contribute by 30%. That's it. We forget.
It is not increasing by 30%. It is just contributing.
It will contribute 30%. Yes. How to select the cutoff value? You are speaking about the cutoff value. Am I right? So you have taken the cutoff value as 0.5. If anything less than 0.5, you are mentioning it as 0. If anything greater than 0.5, you are mentioning it as 1. Selection of cutoff value. I'll come to the cutoff value sometime later. Now, you forget about if something is less than 0.5, it is 0. Something greater than 0.5, it is 1. We'll have a right cutoff value based on the selection of the AUC and the ROC value. Now, my objective is, are you able to understand this? I've given some random value 111 by using the what we'll call it as MRG, GRG nonlinear. This is the solving method that I've used. Using that, I was able to come up with the intercept values for the loyalty, the brand, product, and shopping. and I have got an intercept value also. So what you have to know, the odds, the formula for an odds is exponential of beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. And the probability for the same is odds divided by 1 plus odds, and I given 1 minus probability. This is one important function. How are we going to define it? So going back, it is nothing but the summation y log p plus 1 minus y log 1 minus p. Summation. We have to this is the objective which I wanted to tell here, right? For example, so let me come to one more small example. For example, let me draw a confusion matrix like what could be example? Okay, mailing strategy. I'm coming up with a mailing strategy. This is I'm trying to tell the right cutoff value, how to select the right cutoff value. If I'm going to mail a customer, the cost incurred is $1, and if the person purchases it, profit is equal to $6. $6 is the profit. Now I'm going to come up with a formula. Profit is equal to 6p plus 1 minus profit is equal to $1. It should be greater than 0. I suppose I am right with the formula. So you could, I'll just explain it. If the person purchases it, probability is 6p. And if the person do not purchases it, I have a loss of -1. Do you agree with me here? Any doubt? If the person purchases it, it's 6p. It is a profit. If the person X person do not purchase it, I have a loss incurred of -1. Right? So my overall profit should be greater than equal to 0. Right? So I have 3 conditions here. If it is greater than 0, it is profit. If it is equal to 0, what I'll call it as a break even. If it is less than 0, we'll call it as loss. So I've given up. Since I wanted profit, I've given something greater than 0. So to select the right cutoff value, 6p plus again -1 plus p something greater than 0. Therefore, we'll get 7p minus 1 greater than 0. So p is greater than 1 divided by 7. So here, if my probability is 1 by 7, my right cutoff value, we have always seen in Python or R in Excel, what we used to tell, the probability values, the n probability values, whatever we get, if something greater than 0.5, we are going to mention it as 1, less than 0.5, we are going to mention it as 0. Now here, if I want a profit, I should set my cutoff value something to be greater than 1 by 7. So what is actually 1 by 7? I think 14.14%, right? So I should set in cutoff something 0.1414. Instead of setting it as 0.5, since I wanted a profit, I'm going to set my cutoff as 0.1454. So setting this cutoff is again one important criteria. It's again a complete silence. Okay. Maybe when we are discussing ROC curve, We'll go back and discuss this profit strategy again, right? As of now, we have derived this B1, B2, and B3, right? And what could I do here is, yes, I could do in confusion matrix so that you may more understand. So if the probability is less than 0.5, you mention it as 0 else 1. So this is the prediction matrix right now. So I have a prediction probability. Predicted. So this is the predicted. So this is the actual. So based on the predicted and actual, can I draw in confusion matrix right now? How many is actually 1 and how many is predicted as 0? Right? I think I have done it already. No, I didn't come up with the confusion matrix. But still, can you draw the law? This becomes the actual. This becomes the predicted. Now, can you draw a confusion matrix out of it?
Yes, sir.
So now, what is it? True positive and false positive, false negative, and false positive. So these are the 4, and I'm going to put it over here. This is false positive, false negative, false positive. Let me just delete it. So let me draw a filter here. And what is actually in positive and how many is truly positive? So the total count is 12, truly predicted as positive. Right? Now, truly predicted as negative. So the truly predicted as negative is nothing but how much value? In Excel, I'm not able to see.
12.
12. So truly predicted as positive.
TN. Truly predicted as negative.
Truly predicted as negative. Thanks, guys. Now, falsely predicted as positive. Falsely predicted as positive. Falsely predicted as positive is 3. And falsely predicted as negative is actually positive and falsely predicted as negative. It is again at 3. Since it is in textbook, so it is easy for representation. That's why they have given a very simple way of doing it. So right now we have come up with what color? This color. So if I'm going to plot it in the confusion matrix, what is the confusion matrix is going to be? 0, 1. Again a 0, 1. This is the actual and this is the predicted. Right? This is how your Python file is going to give. So this is how I always remember it. So it's up to you how you're going to remember it. So the truly predicted as positive, TP. Truly predicted as negative. Right? Falsely predicted as negative and falsely predicted as positive. That's it. This is your confusion matrix is going to be. Now I'll just copy paste it and plug in the actual values. Truly predicted as positive is 12. Truly predicted as negative is 12, 3 and 3. Right? Now, if I'm going to forcefully tell if something less than, let me just refer it over here. Truly predicted as positive. Okay, I did not give a formula there. Okay, if I'm going to tell something less than 0.3, do the value change or not?
Yes.
And if I tell if something is less than 0.8, is the prediction value going to change or not?
Yes. It will change.
So it will change. What is the right cutoff value to select? This is one more very important business concept. How to select the right cutoff value?
Maximize the recall or sensitivity or to maximize the precision.
Forget maximizing the recall. How are you going to select the right cutoff? 0.5, 0.4. How are you going to do it? What are the two important terms?
Accuracy and area under curve.
Sorry?
Accuracy or area under curve.
Area under the curve, right? So how are you going to select the area under the curve? You have mentioned the area under the curve. That's really nice. That's very good. Now, how are you going to do the area under the curve? Oh my God. So AUC, area under the curve, ROC. What is this ROC called as, and what is this AUC called as? What is this AUC and what is this ROC?
ROC is the curve name and area under curve.
Okay. AUC is the area under the curve and ROC is? ROC, we call it as a receiver operator characteristic. The total thing we call it as an ROC. Area under the curve is we are going to draw a line, and I'll just show it to you how we are going to plot it. The value under the curve, we'll call it as an AUC value. Alright, so for representation, I have just taken a very simple example. First, let us just understand it, and again we'll go solve that probability value. I think I have introduced this probability value at the wrong time. Now again we'll solve this and we'll go back and see how are we going to see it. Now the y actual is 1, 0 and 1, 0. Very simple. And y predicted probabilities 0.8 and 0.6 and 0.4 and 0.2. So as we always have the rule of thumb, if anything greater than 0.5 is 1, less than 0.5 it is 0. I'm going to validate our thought processes right or wrong. Now I'm going to select a threshold. Something is greater than equal to y is equal to 0.5, 0.2. Is it 1 or 0? Now you guys going to help me. If it is greater than 0.2, it is 1 or it is 0. What is the value here? Am I confusing you here, guys?
1.
So 1 here again.
1.
Here.
1. 1.
1.
Now let us use different colors so that it doesn't become monotone. So if the second cutoff, something is greater than 0.4, I'm going to put it as 1.
1.
Now what happens here?
1, 1, 1.
0.
1 and again 0. Now if something is greater than or equal to y is equal to 0.6. Now what happens here?
1, 1, 0, 0.
1, 1, 0, 0. Now still two more. Y is greater than or equal to 0.8 and y is 1. Now what happens here? Y
1, 0, 0, 0.
1, 0, 0, 0. And what happens for y is equal to 1?
All 0.
All 0.
0, 0, 0, 0. Now, how are we going to plot that in the ROC curve? How are we going to plot that in the ROC curve? How are we going to plot that in the ROC curve? Where shall I draw it? I'll just move a little more. So the ROC curve, ROC is a representation between what and what? The x and y axis, what does it represent?
Is it probability versus number of points? No.
No.
I think
This
AUC
is very, very important.
right,
Yes,
right.
AUC is the?
It's a probability. For AUC is probability versus number of points.
Yes, I don't want those things. What is that x-axis? What is the y-axis? You're
Y
telling
is
probability.
probability.
Probability within what and what?
True positive rate, false positive rate.
Perfect. So we call that as a true positive rate.
Right.
So true positive rate. What is the true positive rate also called as? What is the true positive rate also called as?
Recall.
Sorry, recall or sensitivity. Sensitivity or recall. Perfect. So what about the false positive rate? What is the false positive rate? Just take
Precision.
Specific.
No precision, no specificity. Specificity is right. What specificity? I've given it as false. Just Google somewhere, get the answer something. What does the false positive rate mean? Any answer? So why am I stressing here is this is going to be very important. 1 minus of specificity. So we call this as a sensitivity. This is 1 minus of specificity. Alright guys. So how are we going to plot that? How are we going to plot this in this plot? Any idea? How are we going to plot these values in this plot? So for each and every threshold value, we have to calculate the TPR and FPR. So at the threshold 0, I should also mention the threshold 0. So for threshold 0, everything becomes 1, 1, 1, 1. Threshold y is equal to 0. At threshold 0, what is your TPR? What is your true positive rate and false positive rate? You can see this and you can tell me. What is the formula for a true positive rate? What is the formula for TPR? True positive rate. What is the formula for sensitivity?
True positive divided by true positive plus false negative.
True positive plus false negative. Now, can you see this and tell me? What is truly predicted as positive?
2.
This is truly predicted as positive.
Divided by
This is
1 by
truly
2.
predicted as positive. Divided by, what is truly positive? 2 again. What is falsely predicted as negative?
0, 0.
0. Actually, it is 0. Therefore, it is going to be 1. What is the false positive rate here? What is the formula for false positive rate?
False positive
FP upon
divided by
FP plus
Tn
T
plus
plus FP.
Fp divided by
FP plus FN.
Fp plus Fn. Okay. So falsely predicted as positive.
it should be
Tn.
FP plus Tn. FP divided by FP plus Tn.
Okay. Take your time. Tell me the final call. What is the formula?
FP divided by Tn
Fp divided by
Tn plus FP.
Tn plus Fp. Right? That's perfect. So how did we derive this value? So the specificity, what is the formula for specificity here?
Tn divided by Tn plus FP.
Specificity is given by truly predicted as negative divided by truly negative plus false positive. So since it is 1 minus specificity, 1 minus Tn divided by Tn plus false positive. So we are going to come up with this value, false positive divided by Tn plus Fp. Right? So now what is the value over here? What is Fp?
0, 2, 2.
So falsely predicted as positive is 2. Now what is truly predicted as negative?
0.
So it is 0. Falsely predicted as positive is 2. Again it is 1 to 1. So in the plot, where does it fall? What color shall I use? I'll use the red color. So where does it fall?
45 degrees.
Sorry?
45 degrees. 1, 1.
This is 0 and it is 1. So where does it fall now?
Right top.
Here? Here?
I'm not able to see.
Okay, you're not able to see my screen.
Now I'm not able to see the point.
Okay, oh, I'm sorry. So this is where the threshold at 0. Now I want you guys to solve what is the value for 0.4 and 0. Any two 0.4 and 0.8. I want you to solve and tell me the value so that you are very much comfortable with the TPR and the FPR at 0.4. I want answers from everybody. 0.8. So I want the TPR value, FPR value. Isma, Raghu, what is TPR value for at the rate, the threshold at 0.4? Any doubt here? So I want to make sure everybody are clear here. Monica?
Sir, it's 2 by 3.
Okay.
0.5.
Okay.
1
So
by 2.
TPR for here.
0.4 is 0.5.
For TPR or FPR?
Yeah.
How it is going to be 0.5?
Truly positive is 1.
Okay.
Divided by.
Truly positive is 2, right?
Truly predicted as positive is 2, 1 and 2.
Yeah.
Therefore, 2 divided by
2 plus 1, that will be 2 by 3.
how plus 1? 2 plus
False negative. Okay, sorry.
false. Okay, false negative is 0, right?
Yeah.
So TPR is 1. So who Vijay was telling me it is 0.5? Who was telling me? Okay. Vijay, are you clear here now? 2 divided by 2 plus 0, it is 1.
Yes, sir.
Okay, what is FPR? False positive rate? Just put it in the formula. What is false positive? Guess someone for, sorry?
1 divided by 1 plus 1.
So it is 0.5. All right, that's right. And what about threshold at 0.8? True positive rate? Raghu, Isma, you're silent today. Swagata. So what is the true positive rate for the threshold at 0.8? So it is 0.5. And what about false positive rate?
0.
False positive rate is going to be 0. Now, if you're going to plot over here, so I have derived for at the rate 0.2 is the TPR is 1, FPR is 1, and 0.4, 0.8 we have solved, and for 1 TPR is equal to 1 and the FPR is equal to I'm sorry, it is going to be 0 and the FPR is going to be 0. If you have to plot it over this plot, what happens for the threshold at 0.2?
Same 1, 1.
It is more or less, it is going to be the same. Okay, I don't want to plot it for, okay, what happens for plot 0.4?
1, 0.5.
So this is 0.5 over here. Here this is 0.5, 0.5, 1. Here is the threshold of 0.4. Now the threshold for 0.6, I didn't write for 0.6, 0.6, the threshold value, the TPR is equal to 0.5 and the FPR is equal to 0.5. So it is going to be over here 0.5 and 0.5. Do you agree with me? This is for 0.6. Now for what happens for 0.8? Where does it lie?
On the y-axis.
On the y-axis 0.5. Right now, sorry, this is 0.8, right? 0.8. Now, what happens for 1?
0, 0. Origin.
In the origin plot at the rate 1. So now how am I going to plot the area under the curve? So by default, always is going to be, by default, the area under the curve is 0.5, right? So this is the default value. If area under the curve should be always something greater than 0.5, less than 1, right? If it is less than 0.5, there is no point in executing the model. The model is completely imbalanced. Now, if I have to draw the AUC value for this, it is going to come somewhere like this. I'm sorry, it's supposed to be in straight line, right? Whatever the value that is coming under it, we'll call it as an area under the curve. Is it clear, guys? This is the area under the curve and this is the threshold. Now, what is the right threshold to select? What is the right threshold? Next point.
0.4.
0.4 is the right threshold under what condition? Under what condition? Why do you select? Why did you say 0.4? 0.4 is right. Why did you say 0.4?
To maximize the area.
To maximize the area and your true positivity, your sensitivity is 100%. What is sensitivity? The target class, whatever you wanted to predict, is 100%. All right, and you're able to reduce the false positive rate also. The false positive is marginally, it is just 0.5. So 0.4 is a very good option in the case where you want to increase the sensitivity value and have an optimum false positive value.
Sir, I have a request. Can you also explain this in terms of type 1 and type 2 error? Like if we are creating a model from customer perspective and the market perspective, so which one, like we should consider the area under the curve only when we want to reduce type 1 errors?
So if I start, okay. All right, so I can mention only this false negatives, this becomes the false positives, right? So I can explain only one type of the error. The false negative maximum I cannot explain here because I'm taking only the false positive rate and the true positive rate. Okay, there is one big drawback of this ROC value also. That is the next thing which I wanted to tell. So the true positive rate, how much I can, by reducing the error, how much I can, what is the optimum cutoff value that I can select? I think I have not answered your question. I'll come back to this type 1 and type 2 error. I'll select this.
Generally, when we consider only recall for our, like for considering which model is better.
Perfect. So recall we are always considering. You're asking where will we use the specificity?
Yes, yes.
Yeah, the specificity is nothing but Tn divided by Tn plus Fe. I suppose I'm right. True negative divided by false positive. Yeah, this is the specificity. So if our target class, if you are more specific on the target class as 1, the minority class, that is where this ROC and AUC will be of much use, right? I cannot it will be of not much help when I'm going to do the specificity here. So I want to maximize the sensitivity value by very less false positives. This negative values I cannot do using this AUC value. That is one drawback in this ROC AUC. I can only see between this true positive and the false positive rate. Selection of cutoff. So if I have to maximize the sensitivity value and I want to minimize this false positive value, So that is how the optimum cutoff value is selected. So can you tell where the 0.8 will be of much use? So
I don't want any false negative rate.
False positive rates.
So yeah, false positive.
False positive rates. So you do not want even a single false positive rate to be here. You are very much concerned about, I do not want even single false, I do not want it to be there. So you're going to give up your sensitivity value over here.
Sir, so in terms of precision, when precision is where we don't want false positive rate, right? So will that, like, I just want to confirm my understanding, will that be the 0.8 variable?
True positive, true negative, 0, 1, 0, 1. This is the actual, this is the predicted, right? This is the falsely predicted as negative, falsely predicted as positive. So what is precision here? What is precision? So just simply tell, I do not want formula. So what is the precision? TP divided by false positive. So how much have you predicted actually positive? What is the strength of your prediction? So that is what is your precision is. So how do you want me to compare over here? So what is your question? I'm not able to frame myself properly.
So my question was, will like not having any false positive rate can be equated to precision? Because I mean, when we want to have maximum precision, then we will not have any false positives, correct? Like that is what ideal situation we want. I mean, it will not happen in the market. But
see, false positive rate. The false positive rate or 1 minute specificity is given by false positive divided by Tn plus Fp. I think this is the formula. Fp divided by Tn plus Fp. So how can you validate between this precision and this false positive rate?
Okay, so I think I was confused a little. Okay, thank you, sir.
No.
What I was that if we don't have any false positive rate, that will be like minimizing false positives. And
yes, you are going to minimize the false positives. Okay.
When we want to minimize the false positives, then our precision will be high, right? If we are not having false
positives. Yes, you're false positive, then your precision is going to be higher.
So in a model where we really want to consider precision, like the money laundering cases and
falsely predicted as.
Correct. So there, the threshold value in our case should be 0.8, if I'm not wrong.
Yeah, falsely. Yeah, somewhere like in medical field, not in money laundering. Money laundering also falsely predicted as positive. He can sue and he can come up. You are falsely predicted a cancer patient. Yeah, like okay.
Right. Yes.
You're falsely predicting it as positive. So you do not want that to be happening.
Yeah.
At that case, you can keep it as 0.8. You're right.
Okay, thank you. I just wanted to confirm because I was confused little between.
So did I answer your query or not?
Yes.
Or we'll go back again.
Okay. No, it is answered. Thank you.
Okay. So there are two ideal situations. Why did I take this simple example? This I have framed it and I've little I've derived it from somewhere else. So how did I wanted to frame is like, how can I compare this value to the AUC value? So I thought I did some mistake while deriving it. So this 0.4 and 0.8, these are the two optimum values to be selected on whichever domain it is very much suited for. So I'm very much highly skeptic about the sensitivity value. I want 100% and 0.4. I do not want even a single false positive rate. At that situation, 0.8 is the right value, like what Monica said. Right? Is there any trouble in understanding this concept, guys? So I think this was missing. So I've taken an extra step to decide derive these values. This was not part of our presentation itself.
So this was very helpful. Thank you. I mean, I had a lot of confusion on the confusion matrix between recall and
matrix.
Yeah.
But
now, same here, sir. Same here.
Thank you.
So this maximizing, so the AUC value should be something greater than 0.5. An optimum in case 0.75 should be a rule of thumb. It again depends on the domain. If something is less than 0.5 or 0.5, there is no point in executing the model itself. Right? The data self itself is a biased model. So that was the reason I have taken very simple that 1010 how to derive this true positive rate and false positive rate, and I have come up with the AUC and ROC value. So similar to that only, I wanted to explain about this simple example, the mailing strategy. This was an example which was taught as part of our program. So I just try to recall. So if I mail to a person, if he purchased the product, it is $6 profit. If I mail to a person and the cost of mailing incurred is $1. So if I mail to a person and if he purchases it, $6 profit, and the cost incurred is $1. So if he purchases it, my profit is $6 into the profit plus 1 minus of P. If he does not purchase it, then the value that I'm going to give here is -1 because there is a loss of $1. So what is the right cutoff to select? So if I'm going to give a confusion matrix before and after, for example, before doing, there were 972, 2 and 76 and 5. I'm sorry, I cannot put that lines here. So after selecting the cutoff 829, 90 and 43 and 38. So just a simple random values. So what is the change between this and this? What is the major change between this and this? This is nothing but the confusion matrix, guys. PP, TN, FN and FP. So what is the difference between this and this? 1 and 2. This is after imputing the cutoff of P 1/7. So what is the difference between this and this? What all have changed?
False positive have increased.
False positive have increased. So in the sense, the true negative have decreased. And what is the important point here? And what is the one more understanding from this table?
Sensitivity has increased.
Sensitivity have increased. The sensitivity have increased. So have given some errors in the false the false positive, so that I could increase my truly predicted as positive. So this is a situation. I want to find the target customers here. So I have traded off between my false positive and the true positive. False positive and true positive. I've traded it many truly predicted as negative as false positive, and I've correctly predicted the customer who are going to buy by deriving in small formula. What is the right cutoff value here? Right. So when you start working on real life, you have to derive small formulas like this to find the optimum cutoff. It is specific to the domain. Else the ROC and AUC values are good enough. Right. Theoretically, all these are good enough. Once you start working as an industry person, I can only tell that. So you have to work a little more how to find these cutoff values. Something like since I have taken a very simple example, I have derived a value. This could be the right cutoff. So by using this cutoff, I was able to increase my sensitivity value. When you're going to present some values, you should have the ability to increase your cutoff value. I mean your sensitivity value. ISPA, how optimum cutoff is 0.4? Do you want me to explain again, or this message was sent some time back? So the optimum cutoff 0.5 I have selected because the sensitivity value is very high here. Am I able to answer your question? Okay. Okay, fine. All right. Going to the next point. So I derived it over here. This is one important thing which I wanted to derive, and so I have derived the complete thing in the Excel. All right, but we'll see it in the Python. So I've just standardized and I've used the same concept. All right. Then I've derived the log odds and I've maximized the likelihood. Right. Now going back to our Python file or case study. So, or can someone take a lead and read this question?
WHO is a specialized agency of the UN which is concerned with the world population health. Based upon the various parameters, WHO allocates budget for various areas to conduct various campaigns or initiatives to improve healthcare. Annual salary is an important variable which is considered to decide budget to be allocated for an area. We have a data which contains information about 32,561 samples and 50 continuous and categorical variables. Extraction of data was done from 1994 census dataset. The goal here is to build a binary model to predict whether the salary is greater than 50,000 or less than 50,000.
And 50,000. Right. So our objective or dependent variable is greater than 50,000, 1 or less than 50,000, 0. Right. We have a data set. This is about the world population health. Some data set we have taken it up. Various campaigns. I will look at the data dictionary. So we have taken the attributes, is not attribute. Attributes, various attributes that we have taken. The age, the work class, right? This is supposed to be sampling weight, I think so. And the highest education the person had, the education number of years, and the marital status, the occupation, relationship, the race, what is the sex, what is the capital gain, capital loss, and the working hours. The capital gain is the income investment sources other than the salary and wages that the person has got, and similarly the losses for it, the working hours per week, the native country, and the salary. This is the data set that we have taken. So this is the derivation. This is the data set that we have taken. One second. The age, the work class, whether it is in federal government or the local government, he has never worked. The private, you can see there is a question mark and foreign symbol here. We have to remove that, right? So the sampling weights and the education number of years, the marital status, whether it is divorced or never married, separated, widowed, the occupation. So we have so many number of variables, and there are so many other variables. Some question mark is there. So we'll clear the data, right? And we convert whether it is greater than 50,000 or less than 50,000. We'll first convert. If it is greater than 50,000 is 1, less than is 0. All right. Any doubt in this data set? Shall I go ahead to Python file?
Yes.
Yes, sir.
Now going to the Python file. Okay, we had here itself. The solution is okay. I'm using all the libraries here. I'm just importing the data. Okay. So the exploratory data analysis, I'm just giving the head. So what are all the data present? What is the nature of the data? Integer, the age, the work class is an object, the education is an object, marital status is an object. Object is strings. These values are all strings. The capital gain is an integer. These are all numerical values. The native country is a string. The salary is an object. So we have to change to the respective types. Right? Now check for the duplicates data. Is there any duplicates present in the data? So how do we check the duplicates present in the data? So adult data, right? And what do you call it as? Duplicated. And since it is a function, double quotes. So we have 24 duplicates that should be removed. So by dropping duplicates is nothing but drop duplicates. It is going to remove all the duplicates. So recheck adult data duplicated, right? Dot sum. So there are no duplicate data present here. Getting the unique counts of each and every object. So if we want it in the proportion, we are going to give it as normalize is equal to true, right? So checking whether the data is balanced or imbalanced data. It is not in complete balanced data. It is somewhat an imbalanced data. 75% to one class, and our target class is a minority class. So usually in minority class, we are going to give it as 1, and the majority will be giving it as 0. Right? So for the sake of time, we have given all the for loop here. Right? So whatever is object, just show me the value counts of it. So work class, something unknown value is here, 1836. All right, again one more, again here also the occupation, something unknown, 1843. These are all unknown values. We have to treat these values. So what are the number of male, what are the number of female, right? So for all the categorical variables, we have the count. So work class occupation has the question mark. Since higher number of K, we will convert them to a new level. All right. So complete the 3 lines to replace question mark to one more category. All right. So which had a question mark?
So salary. Oh no. So occupation.
So what I'll do is we'll generally make everything. Okay, work class is here. So work class and
class, occupation, and native country.
Native country. Okay. First, let us treat the work class, and we'll give string replace. Back from our quiz 2. String replace. We have used much of string functions then. 2, we are going to convert to unknown category, right? So on the occupation, we had one more occupation. In the occupation, str dot replace this question mark to unk, right? So, again.
So what is the difference between string replace and to replace? There is
to replace.
Yeah.
So in to replace, it works for numerical. This since it is all strings, right? You have to give it as string.
Thank you.
Okay. String replace the question mark to unknown. Right? I think only these 3 were there, right? Okay, I've converted it. So again, describe all. So this include all, it is going to show even the categorical variable, right? So we could see for the age, the mean is 38.5 is the average age, and the standard deviation is very high. The age is 13.6, right? The and what else was the numerical variable? And the education number of years, we have a mean of 10 years of education and then standard deviation of 2.5, right? So these are all basic summary level stats, that summary level of what the descriptive stats that we can look at here, and check for the outliers. So adult data dot box plot, which all values as an outliers. This FNL WGT has outlier. Is this variable actually required or not? We'll see it later. Now, as of now, this has one outlier, this has many outliers, education number of years has. The major problem here is this becomes a dominate. Because of that, we are not able to look at the values of these. Right? There is outlier present in capital gain, education number of years, and working hours per week. There are quite some outliers. So to remove the outliers, I've used a very simple concept of capping. The lower range and upper range, we have just used the capping concept over here. So do you have any doubt here, capping?
No, sir.
All right. So again, once it is capped, let us look for the data. So we could see that majority of our outliers are removed. Removed in the sense we have capped the value. Therefore, the outliers cannot be there. Right? Checking for the correlations. So what does it tell? Why is it not coming? I have done something and
No, sir. In the next description they've given, then capital gain and capital loss after capping will be 0. So we remove these.
okay. Okay. So no. Okay. Sorry. Yeah. The values are by itself are not present. Okay. So we could see here the maximum outlier is given by 1.0. So not many are interrelated. Not many of the variables are interrelated, and these variables are not there. All right, capital N gain and capital loss are both 0 after removing the outliers. Hence, these variables can be removed. You could see here capital gain. The mean value is 0. The capital loss is again 0. So these both variables are not readed at all. So capital gain after removing the outliers, these two variables can be dropped. All right. So to drop the variable, adl data dot drop. So how do we drop it? I have to use capital gain capital loss, right? So is this right here? Am I missing something?
In place equal to true.
Okay, still am I missing something?
The axis is equal to
Perfect.
1.
So axis is equal to 1 is a must to mention it, right? 0 by default, what happens in Python is it takes 0, axis is equal to 0. If you have to remove the column, you have to mention axis is equal to 1, right? These small things that will take some of your time when you start doing your assignments or something, right? So after that, you could see still not many of the variables are correlated. Therefore, it's okay. I'll tell you the assumptions when I'm trying to close the session. I'll tell you two more things. What are the assumptions of logistic regression and how to use it collab, right? So and then the pair plot. Once you start working for any industry, or if you participate in hackathons, or by your own interest, you're looking at many of the data set, this pair plot becomes your atma, right? How good is it separating? Which are all variables are good, right? Just by this basic pair plot, it will be of very much help, right? Not many of the variables are of much use, right? See, these are not separating this true positive and the false positive, but still we'll see. And then again converting the all objects to the categorical values and just checking it. So what I have taken is I have taken the data out of it at this point, and then I had worked on this based on the formula. We'll see at last, if the time permits, we'll check. So it's not the issue. We have seen one simple example. Based on that, you can derive the same thing also, right? So the train and test split, the adult data, I want to drop the salary and then adding it over here using the model selection, train test split. Now coming to the logistic regression model, right? The logistic regression model, what is the function that we are going to use? The logistic regression is given by logistic regression, right? Model. I'm just saving it as a model. So model dot fit x comma y, right? So okay, this case I have put it in capital X comma y, right? Now I have fit the model. So this error, if some warnings like this pops up, I'll just give you an workaround. Oh yeah, you could just use this. It is not going to harm you. It's just giving you some intimation. Don't worry about it, right? So you could remove that import warnings.filter warnings and just keeping it handy. All right, so the model is fit. Now I want to predict the model, right? I'll save this model fit into y_predict.
This brings us to the end of this predictive analytics tutorial. Now, before you guys sign off, I'd like to inform that we have launched a completely free platform called Great Learning Academy, where you have access to free courses such as AI, cloud, and digital marketing. So guys, thank you very much for attending the session and have a great learning ahead.